Everybody, in this video, we're going to continue with scientific notation and look at how to multiply and divide with scientific notation. Scientific notation. All right. So we're multiplying and dividing while staying in scientific notation. So we're not switching to the standard form here. And again, as you're setting up your notes, feel free to add in your date or the week in which you're working to help you stay organized. And the thing that happens here actually that's pretty interesting is we actually use things we already know. So what we're going to do here is we're going to apply the product and quotient rules for exponents, right? Because if you think about your scientific notation, you have exponents there, right? And you have them all to the same power, which is key. Everything is all to the same base, excuse me. Everything is base 10 to some power. So because they all have the same base, we're actually able to apply the product and quotient rules for exponents pretty easily. So let's review those real quick. So the product rule says that when you have the same base and you're multiplying, you can just add the exponents. And the quotient rule, remember, says that if you're dividing with the same base, we can subtract the exponents. So that's what we're really going to use here to simplify scientific notation. And it's easiest to just do with some examples. So here I have two numbers that are written in scientific notation, and I'm going to go ahead here and apply my rules. Now notice that we're multiplying here, so this is going to end up using the product rule because we're multiplying. Now, if you can do this in your head, that's fine. I like to usually rearrange. So what I'll do is I'll put my numbers together, right? Because 8 and 7 don't have powers or anything like that. So I'm just going to do 8 times 7. And then I'm also going to do my powers. So I have 10 to the negative 6 times 10 squared. And then I'm just going to use my rules. So 8 times 7 is 56. And we're multiplying here. And then here, if I'm multiplying, I'm going to add the exponents, which is what that product rule says to do. So it's going to be 10 to the negative 6 plus 2. And I get 56 times 10 to the negative. Now, at this point, you have to decide how do you want your final answer? Do you want your final answer in scientific notation, or do you want your final answer in standard form? So you could do either. We do want to be a little bit careful here, though. This number is actually, in this case, not in scientific notation because that 56 is too big. So what you can do here, if you are, let's say you want your answer in scientific notation, it's not quite there, well, we could switch it to standard form and then rewrite it if we want to. So let's just write our answer in both forms. Okay. So if I go to standard form here, right, remember that exponent is going to tell me how many spots to move and what kind of number I have. So a negative means I have a small number. And that 4 means I'm going to move 4 spots. Now in my 56, the decimal point is on the right. So I'm going to move it 1, 2, 3, 4. Now the nice thing here is that even though the 56 isn't in scientific notation, the rules still hold. So you can still very quickly get into that standard form. And if you do want your answer in scientific notation, then we can just take our standard form and convert it back over. So when I move this back to create a number between 1 and 10, 5.6, I move it 1, 2, 3 places, and again, it's going to be a negative sign because that number is small. I'm going to do another example. I'm going to go to the next page, though. So another multiplication problem here. And again, what I tend to like to do is I like to just rewrite this. Okay. Kind of grouping my numbers and grouping my exponent parts. Now here, I can't do this multiplication very easily, but I can use my calculator. So I'm just going to do 1.2 times 3.4 on my calculator, and I get 4.08. So I can still do it. I'm just going to do it on my calculator. And then here I have 4 plus 5. So I'm going to have 4 8/100 times 10 to the 9th power. Now, if I want to write my answer in standard form, so that's just as a regular number, then I'm going to notice here that I have a 9. So I'm going to move 9 places. And that value is positive, right? So I know I have a big number. So to make this a big number, I'm going to push my decimal out to the right. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I fill in any holes with zeros. Okay. So 4,080 million here. Now, if you want your answer in scientific notation, in this case, it's actually already done for us because notice 4.08 is between 1 and 10. So this one actually already is in scientific notation because that first number is between 1 and 10, so I don't have to do any extra work. So if you're multiplying, you're basically just going to rearrange and add those exponents. Now we can also do it with division. So let's say I have something like 12 times, let's do 10 to the 2nd power, and then 6 times 10 to the -4. So here we're using the quotient rule. So the numbers we're just going to divide, and then here we're going to use our subtracting. So 12 divided by 6 is just 2, right? So this is just 12 divided by 6. So we get 2. And then here we are going to subtract our exponents. So I have 2 minus -4. Again, be careful when subtracting exponents. It's always top minus bottom, and there is an extra negative there. So it's 2 minus, and then the -4. So in this particular case, a negative times a, excuse me, not a times, a subtraction and a negative make a positive. So this becomes 10 to the 6th power. Now this answer is already in scientific notation because that first value 2 is between 1 and 10. So if I need my answer in scientific notation, I can just leave it. If I want it in standard form, I am going to need to kind of multiply that out. So here you have a positive exponent. So I need to make some sort of big number. So I'm going to end up moving this to the right. Hang on one second. Go. Moving this to the right in this case. So I take that 2, my decimal point would be on the right, and I'm going out 6 places. 1, 2, 3, 4, 5, 6. So I have 2 million. Now, I do want you to notice that when I do my scientific notation, I do use a lot of space, and I do write out intermediary steps. A lot of students just try to do this kind of in one shot or do it in their head because it's not easy, but it's not super difficult. You can do a lot of it mentally, right? 12 divided by 6 is 2. Here, maybe you can subtract mentally 2 minus -4, but I'll tell you that students make mistakes. They make little sign mistakes, they make little errors. or if they don't give themselves enough space, they can't read how many zeros they have to insert. It just gets too squished and too messy. So it's one of those things where, although it may seem silly that I'm constantly rewriting this stuff, it is helpful, because if it's too squished and I try to just kind of do it, then it doesn't work. So for instance, right? So use lots of space, not like this. So a lot of times what students will do is they'll take that value 2 times 10 to the 6th, and then they're like, oh, I'm just going to move my decimal right here. So they're going to put the decimal here, and then go 1, 2, 3, 4, 5, 6, like this. And you can do it that way, but it's really hard to see what you're doing, right? It's like, okay, that's 1, 2, 3, 4, 5, I think 6 zeros, right? It's just so squished and small. So I do recommend rewriting stuff using color and just making things kind of big and overly obvious so that you know how many zeros to insert. A lot of times when students do things like this, most of the time they get it right, but they do make a lot of mistakes because it's just very difficult to read. All right, let's do one more. So here's another example. And again, we're going to use that quotient rule. And here I'm just going to go ahead and divide. Now I have decimals here. I'm going to just use my calculator. So I'm going to just type in 3.48 divided by 1.6, and I get 2.175. So that's all I'm going to do there. And then I'm going to go ahead and subtract my exponents. So -5 minus 2. So I get 2.175 times 10 to the -7. So this is already in scientific notation. I'm just abbreviating here. So because that 2.175 is already between 1 and 10. So if it's already between 1 and 10, then the scientific notation is done. If it's not, then you have some work to do, depending on how you want your answer. So here for standard form, what I am going to do is I am going to recognize that I have a negative here in this particular case. So if it's a negative, I do have a small number, right? So I got to think about how I'm changing this over. I want a small number, so I'm going to move to the left. So I'm going to take my number here. I'm leaving myself some space because I have to go left 7 spots. So 1, 2, 3, 4, 5, 6, 7. Okay. So let's see, I have 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6. Don't forget to put in that decimal point though. It's right there. A lot of times students forget that too. They'll have all the zeros and then they won't have the decimal point. So it's still wrong. You need that decimal point. And then if you want to put the leading 0 in for the whole number, you can. Okay, so there is our final value. Now, maybe this seems like a lot of work, but it's actually pretty easy to multiply and divide in scientific notation compared to having to do out long multiplication or long division, right? So, and even with our calculators, sometimes all those zeros are so hard to just type in and you get them wrong so easily that it's actually pretty nice to be able to multiply and divide in scientific notation. It is possible to add and subtract in scientific notation, although it's not as quick. So we're not going to worry about that in this video. We're going to focus on the main things that tend to be used are the multiplication and division, but do know that you can also add and subtract in scientific notation, but it is a little bit extra work because you would actually need similar powers there, kind of like common denominators. You need the same exponents to add or subtract in scientific notation, so it gets a little bit weird. But don't worry about that. Focus on the multiplying and dividing. If you're interested in learning any more, let me know. I can point you in the right direction. But for us, that's the end of our video.